Hello. So today is the day we get to finally start trigonometric ratios, and I'm so bummed I can't be here, but we'll just do it from afar. So this is section 10.6. It's the last one for this chapter. We're probably going to need to do a little refresher on Monday and finish up, but that's just fine. So again, in your Fourier models, get them out, guys. Give me a pause for the video, and we're going to fill in the definition. So ratios of the side lengths of a right triangle, that's what trigonometric ratios are. They're just ratios of either a leg to a hypotenuse, hypotenuse to leg, and we use SOHCAHTOA, and I'll explain that in just a minute, but give me a pause and copy this. So, hopefully you had enough time to write that down. But so the S in so stands for sine. And sine is just a new word. It's a name for what ratio we're talking about with an angle. So if we have sine of an angle, let's say we're talking about angle A right here. You see it in your diagram? So sine of that angle is O, which stands for opposite. Okay, so I just adjusted this a little bit. So that O is for opposite. A is for adjacent, right here. Opposite, right here. The opposite is just the side that's directly across, opposite that angle. If it's adjacent, it's the one that is touching that angle, but it's not the hypotenuse. So H is our hypotenuse. So that's an easy one. That's always the side across from the 90-degree angle. This one right here. Hypotenuse. So O and H are the two we need to remember. So for this angle A, what's opposite that is our opposite. What's adjacent or touching that is our adjacent side. Okay, so when we write it all out like a ratio, we have the sine of angle A, written sine A, is the opposite length of the opposite, the leg opposite angle A over the length of the hypotenuse. Cosine is the adjacent leg length over the length of the hypotenuse. And tangent, TOA, O is for opposite, A is for adjacent. So if you just remember, SOHCAHTOA, you will not forget. So, sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, TOA, opposite over adjacent. Okay, so let's practice some of these. So we have sine of angle A. We can't really see angle A. There we go. A is right here. So that's the angle that we're looking at. The sine of that. So sine is opposite, so over hypotenuse. So my opposite side to angle A is the one right across, 6. So the sine of A is going to be 6 over hypotenuse. The hypotenuse is right here. That's 10. We always reduce our fractions. They're both divisible by 2. So we get 3/5. So we can say the sine of A is 3/5. Okay, let's switch gears here. We're still talking about angle A for number 2, cosine. Remember, cosine was so CAHTOA. So cosine is adjacent over hypotenuse. Well, adjacent to angle A is this side right here. It's touching that angle, but it's not the hypotenuse. So that leg length is 8, and hypotenuse, it has not changed. It's still 10. We still need to reduce our fraction, and we get 4/5. We could also write this as a decimal, and that would be okay. So the cosine of angle A is 4/5, the ratio of the adjacent leg to the hypotenuse. Okay, the one we have not touched yet is tangent, TOA. So tangent is opposite over adjacent. So we're looking at angle B now. You have to be very careful that you take note of that, angle B. So opposite angle B, if we clear our little diagram here, opposite that is the leg that's not touching that angle at all. See how they are not connected? So that's opposite. So tangent of angle B is going to be 8 opposite over adjacent. What's adjacent? Well, it's touching the angle. There's two sides that touch the angle, these two. But it's not the hypotenuse, it's the other one. That's how I remember it. Not the hypotenuse, but the other one. So that's 8 over 6, which is, well, it's divisible by 2, so we have 4 thirds. All right, and then we are done with that. So let's try some more. This time I want you to actually give me a pause, and I want you to try by yourself or with a partner, tangent and cosine of, we're focusing on angle X right here. So give me a pause, work by yourself or with a partner, give yourself about a minute to 2 minutes, and then push play, check your answers. Okay, so remember we have SOHCAHTOA. Right now we're doing TOA. Opposite of angle X is 20 side length 24, and adjacent to angle X, not the hypotenuse, the other one, is 7. So tangent of X is going to be 24, and we can't reduce that, so just 24/7 is great. The next one, cosine, that's ka, adjacent over hypotenuse, cosine of X. So adjacent to angle X is still 7. That's still adjacent. That was adjacent here. It's adjacent here. So it's 7 over your hypotenuse. Now that's the longest side, 25. So 7/25 cannot be reduced, simplified, so that's it. Okay, now this time, clear our picture. We're talking about angle Y. So give me a pause, give yourself another minute or two, and give it another try with angle Y. All right, here we go. 7/24. So opposite angle Y is 7. Adjacent to angle Y is 24. So that's TOA, tangent, opposite over adjacent. Sine up here. So opposite over hypotenuse. Well, opposite is still 7. So it's 7 over hypotenuse is 25 right here. So 7 over 25. Alright, so we're going to do a little bit of calculator work here. So take a second, grab a calculator. I do not have very many left, so please, I'm begging you, put them back when you're done. You might need to share with a partner today. Okay, so in your calculator, we have these buttons. They are sine right here, cosine right next to it, and the neighbor, tangent. Those are fabulous at finding the value of sine, cosine, and tangent. We can type them into our calculators too, and we get a decimal that way. So the first one, we're going to try it. We're going to grab our calculator and type this sine button right here, sine. And then we just type in 25, sine of 25, and we hit enter. And when we check our calculator, we get point, and it says to round to the nearest, we can't see it, 10,000. Okay, so we're going to have 4 decimal places. So it's 0.4, that's the tenths place, 2 hundredths, 2 thousandths, 6 10,000ths, and there's a 1 after that, so we just leave it like that, 0.4226. So, and that's the sine of 25. Okay, let's do tangent of 15. So, calculator again. This time, we're actually going to type in the tan button. So, find that tan button. Tan of 15. Type it in your calculator. We get 0.2. Ooh, that's a decimal. 6, 7, and 9 with a 4 after stays at 9. So 0.2679. Awesome. Okay. Let's have you guys do a quick pause. Pause me. I want you to try 15 and 13. We're going to do, not 13, sorry. 15 and 16. What am I doing? So sine of 85 and cosine of 5. Give me a pause. Type those in. All right, you should have gotten sine of 85.9962 and cosine of 5.9962. Crazy. And that's all there is to finding a value for these in using our calculators. Okay, we're going to save this for Monday. So on your homework today, I want you to get out your homework assignment. Oh, I want you to have them passed out. 10.6 trigonometric ratios. You guys don't have these yet. And we're going to do numbers 1 through 18. We're going to skip the last 4. I'll come back and talk about those on Monday. And that's it for today.